Hey, I'm Zara, I'm 15 years old, and I don't know how to drive. But I didn't let that stop me from teaching a self-driving car how to drive. I used Udacity's self-driving car nanodegree program simulator to simulate a self-driving car and teach it how to drive using an awesome technique called behavioral cloning. There's a whole lot of thinking that goes on behind driving. Take it from me, who doesn't know how to drive. To humans, most of these behaviors are second nature. But cars don't understand any of that. So to teach a self-driving car how to drive, we would have to manually code all of the different behaviors that are executed on the road. Yeah, no way. That's a lot. I think coding it manually would take a lot of effort. It would also be kind of boring. There is a super awesome, not boring solution. It's this awesome technique called behavioral cloning. Behavioral cloning is when you show an artificial intelligence or AI tons of footage of a human behavior, and then it can mimic this. And this can be applied to cars, and it's exactly how I trained my simulated self-driving car to drive. In fact, behavioral cloning is so awesome that it's how a lot of real self-driving car companies, like Tesla, train their cars how to drive. For this project, I first had to collect training data of a human driver driving, and then I had to let AI learn the characteristics of the human behavior of driving, so that it could execute it itself. Fortunately, Udacity Simulator makes collecting training data super duper easy. All I had to do was drive the simulated self-driving car around the track using the arrow keys on the keyboard. Score! My Mario Kart skills came in handy for this project. Choo-choo! While I was recording the data, for each frame, the car took 3 pictures, all from the front of the car. This allows to create some more variation in the training data. Also, for each frame of the recording process, the simulator records some numerical data, including the speed, throttle, reverse, and most importantly, the steering angle. With the images prepped, it's finally time to build the model. NVIDIA built a really awesome model for behavioral cloning. NVIDIA's model is a convolutional neural network that maps the correlations between the steering angles inputted by the human driver and what the car saw on the road. The convolutional layers extract features from the images, for example, what the lane lines look like. As images go through the model is continuously trying to predict the correct steering angle. Every time the model gets the steering angle wrong, the model slightly readjusts itself and tries again. Over time, the model optimizes its accuracy and reduces its error. The model is finally trained, and now it is go time. The moment of truth. I let the car drive around the track using the predictions from my model. And that's really unfortunate. The car was never taught what to do when it was on the side of the road, because none of the training data involved the car being on the side of the road. So when the car found itself in that situation, it had no idea what to do. It got confused and drove off the road and into a lake later. To solve this problem, I decided to implement something called recovery data. This is basically just showing the car how to recover when it's in one of these unideal situations. I went back to training and collected footage where the car started on the side of the road, and I recorded the process of going back into the center of the road. I retrained the model using the old data and the new recovery data, and now the moment of truth. Number 2. Yikes. Okay, so the car did much better. It nearly completed the second turn, but it doesn't drive in the middle of the road for most of this, so it's not perfect yet. So this project is still a work in process, and I'll be looking into more techniques and possible fixes for my project. Let me know what you think. From the 15-year-old who can't drive, I'll get back to you with an update on my progress in this project soon. See you later!